I'm Raullen from IoTex. We are a Silicon Valley startup building auto-scalable and privacy-centric blockchains for Internet of Things. Today I'm going to talk one of the innovative blockchain primitives we're working on. It's called randomized depots for scalable blockchains. This actually works. So depots should be a buzzword given the ongoing launch of EOS recently. So as most of you here should know maybe one or two things about depots. So basically it's composed of three major pieces. One is the BP selection, one is the BP scheduling, and one is the reward distribution. So BP stands for the block producer, which is the authority that is allowed to produce a block given a time interval. And BP is elected by voting from token holders. So in terms of scheduling, basically the order of a BP is assigned programmatically, and each BP ideally should have the identical chance to do the block production. So there's actually not much competing between BPs. So for reward distribution, so BP is getting the token reward as well as the transaction fees, which is optional. And the voters will just get some tokens using some out-of-band mechanisms, which could be really creative, but that's not our focus today. So anyhow, depots have some nice properties. For example, it's very intuitive in design. Basically, it's an implementation of representative democracy on the blockchain, right? And also, it's fast in production in BP because given the entire power of the network is controlled by this 21 guy or maybe 101 guy inside the network, so it should be efficient and also resource friendly. And also, it's very debatable about if it's more decentralized or less decentralized. It's more about more democratic or less democratic. But let's put it as a nice party for now. So when we look at the depots, it's a very good and also natural scheme for IoT, but it's not good enough. So there are two major problems we are facing right now. So given the huge number of IoT devices, which someone said could be 20 billion devices by 2022, so we even want to push the scalability higher for depots scheme. And also second, given the diversities for the IoT devices, application, software, hardware, it needs different chain structures to provide different properties. So for example, in terms of privacy, right? So if you are familiar with confidential transaction, ring signature, ZK snark, Wimo, so on and so forth, you should know they are really tied to the chain structure. So basically, in order to provide these nice properties, you will have to have a consensus mechanism that could support this heterogeneous chain structures. So that's the thing we are looking to do. So that's why we devise and implement this thing called the row depots, which inherits all the nice properties from depots plus some enhancement. For example, it has this horizontally scalable, meaning we can have a multiple group of BPs to just even do more block production for the blockchain. And also, it's more decentralized in terms of we are encouraging even more people to participate in this BP pool. Of course, like I mentioned, it natively supports this heterogeneity of the chain structure, and also instant finality of the block would be very important to us. So how does this work? You may wonder, what's the mastermind, master idea behind all of this magic? So it turns out to be actually it's pretty simple. So the core idea is we have a larger pool of delegates, we call it candidates, and every epoch means maybe 100 rounds, 200 rounds. A small group of delegates will be selected out of this larger pool using a randomized, also crypto verifiable way, and they are sorted somehow. And then this block this small group of delegates will run a PBFT variant, which we designed to reach consensus on the block, and then to broadcast the block to a network. In addition to that, we also optimize the bootstrapping process, given a EOS launching is ongoing forever. So we have this seamless bootstrap process without relying on ABP, which stands for appointed block producer. Of course, we were facing academic and engineering challenges when we were doing all of this stuff. For example, PBFT is definitely not efficient enough. But somehow, we designed a new scheme called Scalable PBFT. It depends on threshold signature. So it's a very cool scheme, and the paper is under review. I encourage everybody to go there and take a look. And also to get this like a non-interactively ordering of BPs, we design our own crypto sortation function, which is composed of DKG, decentralized key generation, POS signature, and using like a new hash function, Black2B. And also in terms of bootstrap the network, actually we piggyback on the Ethereum blockchain, and we do like election, voting, everything there. And then once it's materialized, we just migrate the states to our blockchain to start the entire IoTex blockchain. Yeah, so I can give you some examples about how this flow works. So basically, you have some token holders, so they will vote somebody, so we will form a candidate pool. And this, in each epoch, like a very small group of delegates, let's say 21, will be selected out of this candidate pool to form this group of delegates, right? And then they will run a DKG to get like secret shares, which will be used later to update the seed. Within each epoch, we have different sub-epochs, and within each sub-epoch, we have different rounds. In one round, like one of the delegates will play the role of proposer, who propose a block and send it to all the peers, all the delegates, and all the other delegates will play the role of validator. Of course, they will do some PBFT kind of thing to reach the consensus on the block the proposer produced. And once the consensus has been reached, this block will be committed, so on and so forth. So that's kind of idea behind the role depose. So in addition to design and implementation of the role depose scheme, we also work with blockchain researchers from Berkeley to actually trying to build up a simulator for POS schemes in general. Like, because we want to catch logic bugs in the POS scheme at a very early stage, and also we want to try this consensus at a very large scale to basically do some performance benchmarking and tuning, right? Because like without running this against a very large scale, it's really hard to convince at least myself to believe in like if this scheme works or not. So the methodology we're taking is we want a simulator to be generic enough for almost all the POS schemes, including starting with the role depose. And then this simulator should have a fast and a parallelable simulation, meaning like if you want to run this consensus on top of 100 nodes for like let's say 10 days, you don't actually have to wait for 10 days. Maybe just take a couple of hours to get it done, right? So, and also like for simulators, it should work with different policies. We have distinct network topologies we can configure. We can configure even for like connectivity for different nodes in the network, given that we are working on the IoT scenario, which is definitely necessary. And also each node can play different roles. Some could play like honest players, some can play like BFT attackers, some can play like false stop players as well. The outcome of the simulator should be like several metrics around liveness and safety for this protocol. So I want to show you like a very simple example we have here. I'm not sure how can turn it on. Oh, actually it's on. So basically this demonstrates we have like a 10 nodes network running role depose. They are trying to talking with each other, proposing blocks, trying to vote, do whatever they want. Then at a certain time interval, then everything is good. Consensus has been reached. So that's kind of thing like we want to visualize for every post scheme to catch logic bugs at a very high level. Also, as I mentioned, like the outcome of the simulator is some metrics. Like this, for example, one of the metrics we have, it could be a very simple one. It's latency versus TPS, which is very straightforward. Like as latency increase, as you can see, the TPS drops sharply. So this is the data we get in an environment with 10 nodes, and each node with 2 connections to its peers. We have like even more interesting data like this. Basically, to conclude, so IoTex is developing innovative blockchain primitives. For example, we are using something called blockchains in blockchain, and role depose, as I already introduced, and we have one recently. It's called lightweight steel address, and there are some other privacy technologies we are working on. So we are trying to bring this like autonomous device coordination to the world by connecting the physical world block by block. And last and not least is like we are hiring. We are Silicon Valley startup here. So if you are interested in IoTex and all the research work we are doing right now, feel free to talk to me and my team here. We will stay here pretty late. So yeah, that's it. Thank you.